Hello friends, hope you're fine. In this session we will discuss the topic acceleration. An object is said to be in uniform motion along a straight line when it covers equal distance in equal interval of time. During uniform motion of an object along a straight line, its velocity remains constant over the time. Let's keep that in mind. The velocity remains constant over the time. Let v1 and v2 be the velocities of object having a uniform motion at time t1 and t2 respectively. The change in velocities between time t2 and t1 is given by v2 minus v1. As the object is in uniform motion, we can say that v1 is equal to v2 equal to v. Then the change in velocity will be v minus v. That is, change in velocity is 0. Then we can say that for an object having a uniform motion along a straight line, the change in velocity of the object for any time interval is 0. So far we have discussed about object having a uniform motion. Now we are going to discuss about object having a non-uniform motion. By the definition, an object having a non-uniform motion along a straight line when it covers unequal distance in equal interval of time. Unequal distance in equal interval of time. During this type of motion, the velocity does not remain constant over the time. Or we can say that the velocity varies with time. That is, the velocity have different values at different instants of time and at different points of the path. Thus, the change in velocity of the object during any time interval is non-zero value. Okay, can we now express the change in velocity of an object? To answer such a question, we have to introduce another physical quantity called acceleration. Yes, it is. Now, acceleration is a measure of the change in velocity of an object per unit time. Acceleration is given by the equation acceleration equal to change in velocity divided by the total time taken. Consider an object having a non-uniform motion and the velocity of the object is increasing over the time. Let's measure the velocities at two instants of time, say at time t1 and time t2. At time t1, the object is moving with a velocity of u. After some time, say at time t2, the object gains a velocity of v. From this assumption, it is clear that we are considering only the velocity values within the time interval t1 and t2. At time t1, the object have an initial velocity of u, and at time t2, the object gains a final velocity v. This velocity change occur over the time t, where t is given by t2 minus t1. We know that acceleration is the measure of the change in the velocity of the object per unit time. Acceleration is given by the equation acceleration is equal to change in velocity divided by the time taken. Let's find out how fast the velocity changes per unit time, or the acceleration. To solve the acceleration, first we have to find out the change in velocity. The change in velocities between time t2 and t1 is given by the final velocity minus initial velocity. If initial velocity is u and the final velocity is v, then the change in velocity equal to v minus u. Then the acceleration is given by acceleration is equal to change in velocity by time taken. That is, acceleration is equal to v minus u divided by t, where t is t2 minus t1. Then we can say if the velocity of an object changes from an initial value u to the final value v in time t, the acceleration a is given by a is equal to v minus u divided by t. This kind of motion is known as accelerated motion. The acceleration is taken to be positive if it is in the direction of velocity and negative when it is opposite to the direction of velocity. Since acceleration is the change of velocity divided by the time, the unit of acceleration will also be the unit of velocity, that is meter per second, divided by the unit of time, that is second. Then the SI unit of acceleration is meter per second square. The other units of acceleration will be centimeter per second square or kilometer per hour square. If the motion in a straight line, acceleration takes place in the direction of velocity, therefore acceleration is a vector quantity. Consider an example of the velocity of object increasing over the time and the body is said to be accelerating. Suppose a car starts from the rest, that is, its initial velocity is 0 and its velocity increases at a steady rate so that after 5 seconds its velocity is 10 meter per second. Now in 5 seconds the velocity has increased from 10 minus 0, that is 10 meter per second, and in 1 second the velocity has increased 10 divided by 5, that is 2 meter per second. In other words, the rate at which the velocity increases is 2 meter per second in every second. The car is said to have an acceleration of 2 meter per second square. It is clear from the definition of acceleration that A is equal to V minus U by T, that an object is moving with a uniform velocity, its acceleration will be 0, because then the change in velocity is 0. Thus, we can conclude that when the velocity of an object is uniform, the acceleration is 0, and when the velocity of the object is non-uniform, that is, it is changing or varying over the time, the motion is accelerated. Let's discuss about uniform acceleration. When the velocity of a car increases, the car is said to be accelerating. If the velocity increases at a uniform rate, the acceleration is said to be uniform. A body has a uniform acceleration if it travels in a straight line and its velocity increases by equal amounts in equal intervals of time. In other words, a body has a uniform acceleration if its velocity changes at a uniform rate. Let's consider some example of uniformly accelerated motion. The motion of a freely falling body is an example of uniformly accelerated motion. Also, the motion of a bicycle going down the slope of a road when the rider is not pedaling and the wind resistance is negligible is also an example of uniformly accelerated motion. The motion of a ball rolling down an inclined plane is an example of uniformly accelerated motion. The velocity time graph of a body having a uniformly accelerated motion is shown. From the velocity time graph of a body having a uniformly accelerated motion, you can see that it is a straight line. Okay, let's discuss about non-uniform acceleration. A body has a non-uniform acceleration if its velocity increases by unequal amounts in equal interval of time. In other words, a body has non-uniform acceleration if its velocity changes at non-uniform rate. The speed or the velocity of a car running on a crowded city road changes continuously. At one moment, the velocity of the car increases, whereas at another moment it decreases. So, the movement of the car on a crowded city is an example of non-uniform acceleration. The velocity time graph of a body having a non-uniform acceleration is a curved line. Let's consider retardation or deceleration or negative acceleration. The acceleration takes place when the velocity of a body changes. The velocity of a body may increase or decrease according to the acceleration of two types. Okay, let's consider retardation or deceleration or negative acceleration. Acceleration takes place when the velocity of a body changes. The velocity of a body may increase or decrease. Accordingly, the acceleration is of two types: positive acceleration and negative acceleration. If the velocity of a body increases, the acceleration is positive, and if the velocity of the body decreases, the acceleration is negative. Usually, most people use the word acceleration in those cases where the velocity of the body is increasing, whereas decrease in velocity of a body or slowing down of a body is known as retardation. It is also known as deceleration or negative acceleration. A body is said to be retarded if its velocity is decreasing. Retardation is measured in the same way as the acceleration. That is, retardation is equal to the ratio of change in velocity to the time taken. It is given by the equation retardation equal to change in velocity divided by the time taken. Retardation has the same unit of meter per second square. Retardation is actually acceleration with a negative sign. Consider an example. When a car driver traveling at an initial speed of 10 meter per second applies a brake, brings the car to the rest in 5 seconds. That is, the final velocity becomes 0 meter per second. Then the acceleration is equal to the change in velocity divided by the time taken, given by acceleration is equal to final velocity minus initial velocity divided by the time taken. Initial velocity is 10 meter per second and the final velocity is 0 meter per second as the car stops. This change takes place in 5 seconds. So acceleration is equal to 0 minus 10 divided by 5. Acceleration is minus 2 meter per second square. Thus the acceleration of the car is minus 2 meter per second square. It is a negative in sign, but the negative acceleration is known as retardation. So the car has a retardation of plus 2 meter per second square. It should be noted that the acceleration of minus 2 meter per second square and the retardation of plus 2 meter per second square are just the same. The negative value of acceleration shows that the velocity of the body is decreasing. When a body is slowed down, the acceleration acting on it in the direction opposite to that of the motion of the body. Thus, we can have the acceleration in one direction and the motion in another direction. Okay, let's solve some problems. Question number 1. Starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Then he applies a brake such that the velocity of the bicycle comes down to 4 meter per second in next 5 seconds. Calculate the acceleration of the bicycle in both cases. Solution. From the statement of the question, velocity is varying over the time. This variation happens in two parts. In first case, the velocity increases from 0 meter per second to 6 meter per second in 30 seconds. That is when Rahul starts pedaling, and in second case, the velocity decreases from 6 meter per second to 4 meter per second as he applies the brake. In first case, there is acceleration, and in the second case, there is a retardation. In first case, the initial velocity u equal to 0 meter per second and the final velocity v equal to 6 meter per second. Time taken t equal to 30 seconds. Then the acceleration a is given by the equation a equal to v minus u by t. Then on substituting the values, acceleration in the first case is given by a equal to 0.2 meter per second square. In the second case, initial velocity is given by u equal to 6 meter per second. The final velocity is given by v equal to 4 meter per second. Time taken t equal to 5 seconds. The acceleration a is given by the equation a is equal to v minus u by t. Then on substituting the values, the acceleration is given by a equal to minus 0.4 meter per second square. The acceleration of the bicycle in the first case is 0.2 meter per second square, and in the second case it is minus 0.4 meter per second square. It is a negative in sign, but the negative acceleration is known as retardation. So the bicycle has a retardation of plus 0.4 meter per second square. It should be noted that the acceleration of minus 0.4 meter per second square and the retardation of plus 0.4 meter per second square are just the same. Question number 2. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration and the deceleration of the bus. Solution. In the question, the unit of speed is kilometer per hour. So we have to convert kilometer per hour to meter per second. How do we convert kilometer per hour to meter per second? The SI unit of distance is meter and the SI unit of time is seconds. This is according to the International System of Units. Now let's do the conversion. We know that 1 kilometer is equal to 1000 meters and 1 hour is equal to 3600 seconds. So 1 kilometer per hour is equal to 1000 divided by 36,000, that is equal to 5 by 18 meter per second. So in order to convert kilometer per hour to meter per second, we should multiply the given number by 5 by 18. The initial velocity is given by u equal to 80 km per hour. This is equal to 22.22 meter per second. And the final velocity is given by v equal to 60 km per hour. This is equal to 16.66 meter per second. Time taken t is equal to 5 seconds. The acceleration is given by a equal to v minus u by t. Then on substituting the values, the acceleration is given by minus 1.112 meter per second square. The acceleration of bus is minus 1.112 meter per second square and the deceleration of the bus is plus 1.112 meter per second square. Okay, let's solve our third problem. A train starts from a railway station and moving with a uniform acceleration attains a speed of 40 km per hour in 10 minutes. Find its acceleration. Solution. As a train was start from the railway station, it has an initial velocity of 0 meter per second. The train attains a velocity of 40 km per hour in 10 minutes. We have to convert the speed and the time. The initial velocity is given by u is equal to 0 meter per second and the final velocity denoted by v equal to 40 km per hour is equal to 40 into 5 by 18, that is equal to 11.11 meter per second. The time taken is t equal to 10 minutes, that is equal to 60 into 10 seconds, that is 600 seconds. The acceleration is given by a equal to v minus u by t and substituting the values we get a is equal to 0.0185 meter per second square. Okay, I have a question for you. When will you say a body is in first uniform acceleration and second non-uniform acceleration? Yes, in uniform acceleration, the body moves along a straight line and its velocity increases or decreases at a uniform rate. That is, the velocity changes at a constant rate in any constant interval. And in non-uniform acceleration, the body moves along a straight line, but its velocity increases or decreases at a rate that is non-uniform. That is, the velocity changes at a different rate for a given constant time interval.